wasn't pregnant?
Yeah.
My sister was supposed to be with me with this, but you're baby now she's not having a baby.
Really?
Yeah.
Technically, if you wanted to make sure you're right, you could say, we're 100% sure that the test score will be between -10 and 200.
For sure.
You're not wrong.
I know.
Unless you do really, really good at really
In the hallway,
Alright. I think we had the first 3 in here. Is that all we got through that 1 minute? Last day I was here. Did we do this next page?
I don't think we just did DDA.
We did DDA in the first 3, and then we're okay. So these are very good test questions. Keep that in mind. And it'd be easy for me to just kind of change one little thing. I could even take, like, so for example, on this one, I could say, I could change that 9,000 to like a 4,000. And then I could even cover up the multiple choice. Like, you just give me an answer. So you can't just memorize the answers to these, but you can memorize like the concepts, the ideas behind them. Alright, so they tell me in this one, I have a sample of 9,000, and then I'm going to do it again with a sample of 1,000, so my sample size went from 9,000 down to 1,000. So hopefully you know that a bigger sample size makes things narrower, right? I mean, the smaller one has to make things wider. Well, it got 9 times smaller, so does it make it 9 times as wide? It does not make it 9 times as wide, it makes it 3 times as wide. How did I get from 9 to 3? I square rooted. Why am I square rooting? Because the n in the formula is underneath the square root. So if this went from like 16,000 to 1,000, what would the answer be? 60,000 to 1,000. How many times as wide or as narrow? It'd be 4 times as wide, right? Is that right? Number 8. So if you do inverse t of 1.95 divided by 2, 10, that'll get you 2.228. We kind of know A and C. Why did I cross out B? The sample is too small. We got 11. That's not very big. Why is it okay? Right. So, I need you guys to stop talking, please. If you have a question, ask. There's 3 conditions. Is the population normal? Does it say in there the population is normal? It doesn't. Then, if that's not the case, you need a big enough sample size. Are you good?
Yeah.
Okay. Do we have a big enough sample size? We do not. But if that's not the case, we're still okay if our small sample size is what? Is approximately normal, and it does say that in here. A dot of the 11 gas mileage values is roughly symmetrical and has no outliers, so they're telling you it's approximately normal and you're okay. So I get down to A or C, and the only difference is down here, and what goes down there is N, not N minus 1. So it will be A. Is that right? At the bottom one, how will a 95% and a 90% confidence interval differ? So we want to know like which one's wider. Well, the more confidence that you need to have, the wider your margin needs to be. So that's A. 90% will not be as wide as the 95%. And so again, that's just incredibly easy. Like, I'm not fancy about it. When I go give you the test, I'm just going to do this. Be like, okay, pretend it's 85. No, and then I might even get rid of the multiple choice answers. But I'm just going to change like one little thing to make sure you understand the concept. All right, 35. We haven't gotten. This was a tough one. Or 33. This is tough because we haven't done Z's yet. But when you're choosing between T and Z, what matters is if you're in means or proportions. So means, you're going to use T. Proportions, you're going to use Z. That's kind of what this question is getting at, but you don't even know proportions. Yes, this is a tougher one, but it should be A. We're using T basically because we are working with means. We're trying to estimate the population. Which you didn't have anything to compare that to really, so that's kind of a tougher one. 37, so they're asking me to interpret the confidence interval. This is kind of a tougher one too because we haven't talked about everything in here yet, but what am I looking for it to say? Like, what's the key phrase that I want when I'm trying to interpret the confidence interval? Good. Contains the true mean or captures the true mean. None of them say that. So I'm kind of, okay, now what's my next one? Like, what do I try now? Because that one didn't work. If you look at this 15 plus or minus 3, that would give me between what and what? If I go 3 each way, isn't that between 12 and 18? So when they tell me this, if mu is really 19, would this here have been likely to occur? Well, if I'm pretty darn sure that this captures the true mean, and the true mean is 19, like, do these two things make sense together? They don't. Because 19 is not in this interval. If this were like 17, 16, 15, 14, 13, 12, fine, because we're in there. But since we're not in there, those things don't really go together. Yeah. Oh, I thought you about that. Okay.
Can you go through what the others are? Because they're all really similar.
Well, none of them say try to capture the population mean. That's the goal. I want to know about the population mean. So 95% of the population measurements, I can't say anything about the measurements. 95% of the sample measurements, don't care. Sample mean, don't care. X bar is sample mean, so we're talking about the probability of a sample mean being between there, don't care. The confidence intervals talk about the big picture population that we can't see. And that mean. So then, doesn't quite fit. 28 is really similar to, which one was that? Previous page. Really similar to number 8. It should be A. Do I want me to talk through why that's A? I think that was reasonably self-explanatory. Whatever. Like, you don't have to. Yeah. Okay. Okay, why did I choose B for 22? What's the phrase that I saw? Not just population mean, a little bit more than that. There's population problem. Covered the population mean. So that's the same idea as obtained the population mean or captured the population mean. That's what these confidence intervals do. We're making our best guess. That's what the true population mean is. C, same idea. So I'm picking the one that says intervals that include the population mean. That's the goal. That's what we're trying to do there. D, or 25, why not choose D? Include the population mean. So there's a couple of them that say like include the sample mean, or include the data, or include the sample data, or population data. Like I don't care about any of that stuff, it's just population mean. So this page is BCD. Alphabetical. Is that alright? Alright, on the back page. This is a tough one too. I shouldn't even put this on here, but I'm going to talk through it anyways. They get a sample. This is a proportion interval, which is the next thing we're doing. They give me a sample of 55%, so p hat equals 0.55. Margin of error is 3, so that means it's between 0.52 and 0.58. So I go like 3% each way from 55, gets me 52 to 58. So they do not give me any of the ones that talk about capturing the population mean. None of those say capture the population mean. So that's kind of like, okay, now what? It's on to my next. What else can I look at? So then part B, if I said to you, this is your confidence interval, do you think the majority of people favor this? What would you say? I would say yes. I'm 95% sure the percentage of people that favor this idea, whatever it is, or person, whatever, is between 52 and 58. So I'm 95% sure that it's higher than 50%. So do I think it's likely that that more than half of the voters support this idea? I do, because I'm pretty darn sure the true mean is in there somewhere, and everything in there is above 50%. A little tougher because I haven't done it yet, but similar idea. And then D, again, I'm looking at, so this is phrased a little differently, but the mean time is between those two things. 95%. That's exactly how I have you guys word that last box on the template. All right, questions on any of these? Okay, go get a template sheet. Well, go get 2 template sheets over here. I'm gonna write the problem on the back. Then we're gonna do it on the front. So this is, we're moving on to 1 prop Z intervals. How many of you in here would pay higher taxes if it meant no potholes?
I don't drive, so.
I just wish it was
Honest. Also, our roads wouldn't be affected by higher taxes.
They already raised their taxes.
It's a hypothetical.
If I knew my road would be better, maybe. But my cruddy dirt road ain't gonna be big anytime soon.
Everyone's really passionate about potholes.
I didn't know this was going to spark something. Yeah.
Everybody's getting heated.
I know. I've loaded 3 on Saline Island Road.
Did you blow like 2 last year? Like in a row, too?
Within like a month, yeah.
Yeah.
Oh, I know that. Wait.
Now I drive like 30 down Saline Island.
It's so active. You literally just hop into 20 feet and then the cops will be right there. It counts down. I need that.
Dude, can you use it like even when you don't need navigation?
Okay. From this question, before I even start doing before I start doing the problem, I'm going to do a couple things here. I'm going to write down p hat and q hat. So what's p hat in this problem? N is 100. So there is 100 involved. P hat is 0.43. How am I getting that?
43% of them.
43 out of 100, right? So what's Q hat?
0.57.
0.57. So similar idea here. Expected successes, and sometimes you have the count of successes, and sometimes you have a proportion that'll give you an expected count. So this is either the expected number of successes or the actual number of successes. How many successes were there in this situation? And that means how many people support the idea. So that's just a straight up number. And then this is expected failures. Would be 57. How did I get the expected number of successes? The 43 times what? Oh yeah, so you're just saying I read it in the problem. Mathematically, how can I get to it?
Times N by P hat.
So it's N times P hat. And what does that have to be greater than or equal to? 10. That's one of the conditions. N times Q hat has to be greater than or equal to 10. You forgot it because it's not true for means, so we haven't used it in a while. But one of the conditions is that N times P hat has to be greater than or equal to 10. All that's saying is that the expected number of successes have to be greater than 10. So you can write this either way. Because sometimes they'll give you like an actual count. So you can do this N times P is greater than or equal to 10, and you can go 100 times 0.43. There's 43. Or you could just say like, yeah, there's 43 successes, that's bigger than 10. There's 57 failures, that's bigger than 10. So you can do the math, or you can just take the information. All right. So, what's the first thing we did in the t intervals? We defined mu. So now we're going to define how do I represent population proportion. I'm not looking for population mean anymore. I'm looking for population proportion. So I got 100 people that I surveyed. 43 of them said they'd support more money for the roads. I want to know, okay, what can I do with that information to estimate like the big picture, all the people in mind. So what's that big picture? How do I represent population proportion? It's P. So P equals true. And then remember, P hat is the sample. So P is the big picture, P hat is the small picture. True population proportion. Let's support the tax. And then what? The next, kind of our goal, right? We want to estimate P at a 95% confidence level. So then, before we did RIT, I'm going to do RIN this time. What? What's the R stand for? Randomness. It needs to be stated, or you have to assume it. What's the I? Independence. So you can assume each blank is independent. And or there's that other one where your sample has to be less than 10% of the population. Remember, small n is your sample size, big n is your population size. I think that makes sense. And you You want to be taking less than 10% of the population. Yeah, it's mine.
Doesn't state it.
It's
Because when we were going through the conditions, and it didn't say it was random, but you can't assume it's random, but no.
honestly, I've never seen it come up where they didn't say it was random. Like that was probably one I made up. And so let's just put that in front. It's like always stated, so I wouldn't worry too much about it. Is what I'm saying. And then N is for normal sample distribution, normal sampling distribution. And you need N times P hat to be greater than or equal to 10, which is the same as at least 10 successes. So those are the same. Like you just need one of those. It's the same idea, just phrased. One's in words and one's in like a math formula. And then you need the same thing for Q. So N times Q hat has to be greater than or equal to 10. Or you need at least 10 failures. So why am I doing this? See, I do this every time. I'm doing like the template now. Did you notice that?
Yeah.
I switched
Yeah,
from like doing the actual problem to doing the template. Okay. So let's kind of go back here. Randomness is stated. I'm going to assume each voter is independent. And I also think 100 is less than 10% of all voters. So you don't need that. You need either assume each voter is independent or you need this. 100 is less than 10% of all voters. Sorry about that. I do that. I always want to do the template first, but every time I ask the class, they want to do an example problem first. So in my brain, I'm still doing this. Doesn't matter. Do I have at least 10 successes? Yes, I have 43. Do I have at least 10 failures? Yes, I have 57. Does that make sense? How I took it from like a template to the specific example. Okay. Questions on anything? Yeah? Yeah.
Does it have to be at least 10 for both P and Q, or can it be for one?
Both. So your math box, you're going to start off the exact, we're doing the same thing. Words, symbols, numbers, answer. So statistic, plus or minus critical value, times the standard deviation of the statistic. So your statistic in this case is not X bar. What is it? P hat. So if you look over here, this is these are the two formulas that these will be the two formulas of your next test. T interval, 1 times Z interval. Same setup, right? You put the statistic here, it's means, it's X bar, it's proportions, it's P hat. You put the critical value here, if it's means, you use T, if it's proportions, you use Z. And you put the standard deviation here, and then these are just the formulas that we use for standard deviation of the sample mean, standard deviation of the sample proportion. These should have hats. So P hat plus or minus, it's Z star. So again, I'll write this up here. Means you use T. Proportions, use Z. And then the standard deviation of the statistic is the square root of P hat times Q hat divided by N. So formula with words, with symbols, what comes next? With numbers or data, so P hat in this problem is 0.43. So for Z star, you don't need the degrees of freedom when you're not in means. So you just do inverse norm, 1.95 divided by 2. Z is normal. So we don't need to use T's anymore. We only use T's and means. So you're just going to go inverse norm 1.95 divided by 2. There's no degrees of freedom involved. So I got 1.96. You guys get the same thing? Alright, and then times the square root of P hat is 0.43, Q hat is 0.57, and was 100. Everybody with me? Good? So now we're going to get the answer, which I could do by calculating all the math, but I don't really want to. So I'm going to go to my calculator, and we're going to go stats, tests. It is a one prop Z interval. We have how many proportions are we looking at? Like how many samples do we have? It's just one sample. We have one proportion. Yes, there's the success and failure, but that's still just one sample. Why is it a Z and not a T? Because we're in proportions. And why is it an interval? Because we're trying to estimate something. So all you put in here is 43 out of 100. X is the number of successes. N is the number, the sample size. So you're not putting 0.43, you're not putting 0.57, you're literally putting the number of successes. It's almost like you're writing a fraction, like 43 over 100, and the 43 goes in that spot, the 100 goes in that spot. So a lot of people get screwed up here because they'll try to put a decimal. Don't do that yet.
I got like a P0. Yeah, I got some extra stuff.
Are you doing the one prop Z test?
Yeah.
That's not what I told you to do.
I don't see the
One prop Z interval. One prop Z int.
That's it.
Did you get it? Okay. And then you just put your confidence level, so 0.95. Oops. So the fact that it asks you for those things is actually helpful because you get stuck and you're like, wait, I'm in the wrong spot. I better back up and try to find. So hopefully you got this 0.33 and then 0.53, basically. What do you mean switched? What's switched? Your 0.53 came first. What did you put in? Right here, what did you put in? So, tests and then one prop Z interval. It's down pretty far. It's A. Now you got what I got? It said it backwards? Do you know what you... Oh, never mind. Yeah, I don't know what you do. Alright. Okay. So then at the end, we are 95% confident that what? P is between 0.33 and 0.5. All the other stuff that we've been talking about still applies to this. Like, that's one of the nice things about these. Once you learn how to do any confidence interval, it's really just a matter of changing like the stuff that goes in these three slots, but everything else still applies. So if I wanted to make, okay, let's do this. What's the point estimate here? Nope, not 0.53. 0.43. Isn't 0.43 right in the middle of those two? So what's the margin of error? 0.1, because to get from 0.3 to here or 0.43 to there is 0.1. What's the width? 0.2. If I wanted to be more confident, would this interval get wider or narrower? Get get wider. If I told you that P was 0.25, would you agree with me or disagree with me? You would disagree with me because 0.25 is not it. So all that, like the first 4 times I looked back and you were turned around, I didn't say anything. 5, I got pissed. This is like the 3rd time I've said something to you this class. Is that true? This is like answer my question. Okay, could I not do it anymore, please? Like, don't make me do it anymore. Thank you. So all that other stuff that we were doing, like the confidence interval stuff, still applies. It's just like a different math to get there. Questions on this one? Yeah. You're saying like 0.98 plus or minus 0.05 or something? Even though you can't have more than 100%. I mean, I guess it could. I don't know if it really makes sense. I'd have to see a situation where...
Well, if your mean is close to the top, but they have a margin, could it possibly go slip over because it has to go down either symmetrical?
Right, so you could never really get above 1, but your interval might go above 1. Or other end too. Okay, I want you to do, let's just do the math for like the calculator part. Let's say P hat equals 13 out of 29. Give me a 90% confidence interval. That's it, just do that problem. You'll notice when it gives you the answer, it also gives you like the point estimate. So that 0.448. Do you guys get what I got? Yeah. So you see how it says P hat equals 0.448. They're telling you like what the middle of it is, which is also just the same as 13 divided by 29. How many got this? How many don't have it yet? Are you on the right path? You think so? So 1 prop Z interval, and then you just put in 13 over 29. The next one, X bar equals 10, S sub X bar equals 5, N equals 50. Give me 95% confidence interval. So this is the first time I'm going to do this. Every problem you get from now on basically is it means or proportions. So this one here, which is it's means, I went back on you, right? So you got to be aware on every one of them, which one is it? So this is a 1 prop Z interval. But this one is a T interval. And they're not going to like section off the AP test, like this page is all Z intervals and this page is all T intervals. It's going to be all mixed up and you got to learn to get in the habit of looking for which one's which. So this one I got 8.58 and 11.4. How many got that? Questions on? So we'll practice those tomorrow morning. Just gotta go back and forth. But yeah, I want to hear about the psych class too. So they said it's not online on the schedule? That's what I want to know.
No, it is online.
It is?
Because see, the problem with our school, like, if they said, hey,